Modern cosmology relies on a single, rigid assumption to explain how the universe expands: a static, unchanging substance known as dark energy, represented by the cosmological constant, lambda. But the measurements holding this model together are breaking. When we calculate the expansion rate using the ancient, distant universe, the numbers simply do not match the measurements taken right outside our cosmic front door. This all-sky map visualizes the ancient cosmic microwave background. By analyzing this early light, physicists calculate a global expansion rate of about 67.4 kilometers per second per megaparsec. Then we observe the local universe, using instruments like the Hubble Space Telescope to measure the distance to nearby stars. We get a rate of 73. That is an 8.4% difference, a severe statistical gap known as the Hubble tension. Standard theories cannot bridge an 8.4% gap. To force the math to balance, theoretical physicists have proposed phantom energy models, which inevitably end in a literal, violent tearing apart of spacetime, known as the Big Rip. An independent researcher, Anton Pankratov, offers an entirely different framework to solve the tension through his observer-dependent theory of everything. He argues that the conflicting telescope data is perfectly accurate. The error lies in our definition of dark energy itself. While the standard model treats dark energy as a dead, static parameter filling an empty void, Pankratov mathematically reformulates it. He defines dark energy as an active mechanical process. Viewing dark energy as an ongoing physical event rather than a static substance provides a mechanism to reconcile the conflicting telescope measurements while keeping the core laws of physics intact. The model starts with geometry. Space is constructed from a hierarchy of nested, highly stable, donut-shaped structures called phytori. These geometric structures sit inside one another, separated by strict mathematical jumps in scale known as octaves, mirroring the nested layers of a matryoshka doll. Everything we can see with our most powerful telescopes, our entire observable universe, is locked into one specific tier of this nested hierarchy, labeled as level 9. If we move 3 octaves up the scale, past our known universe, we reach level 12. Here, coherent physical entities exist, called parent-protons. From the perspective of level 12, our entire universe acts as a single internal building block. Our universe is a microscopic component trapped inside a vastly larger architectural framework. These massive parent-protons at level 12 are currently undergoing a massive, gradual cosmic merger. Mathematically, a spiral tracing a path on a torus cannot perfectly close its loop, leaving a measurable gap. This closure failure yields a 2% residue, pi-3 squared. This mathematical friction acts as a physical exhaust that trickles down into our universe. Human telescopes perceive this slowly accumulating geometric exhaust as the dark sector. Specifically, the model identifies the total capacity for dark matter at our level as 26.3% of the cosmic total. The dark sector is the geometric friction of a higher dimensional collision. Because this merger is a physical kinematic process, it operates at a specific speed, governed by a variable known as the chi field. Like any mechanical event spanning vast distances, the merger does not occur at the exact same rate everywhere. It features spatial fluctuations depending on where you look. This map of the chi field provides the exact mechanism for the Hubble tension. Our local cosmic patch is sitting in a localized hotspot, where the merger field is running about 5% faster than the global average. The conflicting telescope measurements are actually both correct. Our local universe is expanding faster because the local geometric merger dial is currently turned up. The strength of this geometric framework is that it is strictly falsifiable. It makes very specific predictions for astronomical surveys in the 2030s. Since each merger event contributes a 2% residue into a 26% dark matter bucket, the math allows for exactly 13 major events before local capacity is reached. Future surveys by the Vera C. Rulin Observatory must find precisely 13 local merger structures to validate this limit. The margin of error is extremely tight. If telescopes find 7 of these structures, or 25, the local saturation limit of the theory fails, and the model is proven wrong. Standard cosmology expects the expansion of the universe to result in either a cold, dead freeze or the violent tearing apart of the Big Rip. In Pankratov's model, once the local merger process hits its maximum capacity of 13 events, the cycle simply completes. At saturation, the universe performs an octave shift. It transitions upward, becoming a single building block in a newly revealed, identical, larger structure. The universe is an eternal, living, recursive geometry.